Hello, thanks for joining me today. We're going to talk about solving equations in one variable. Now, this is the one where we're going to put everything together. So we're assuming that you're pretty good at simplifying. You've done two-step, one-step, two-step equations, and now we're just going to practice doing all the steps. And these are the basic rules that we're going to follow. A basic rule for solving equations is, number one, simplify both sides of the equation. So you just look at each side separately. You don't try to have them interact with each other. So that equal sign is like this bright dividing line between the two sides, and you don't cross it. And you do all the operations that you can do. So you add, subtract, multiply, divide. You do the distributive property over parentheses, exponents if you need to, and get each side, left and right, as simple as you can. Then, second, we will combine all the variable terms on one side. So in this case, we're looking at one with z as the variable. So we're going to get all those z terms to one side or the other of the equal sign. And then whichever side we put the variable on, we want to take all the terms without the variable and put them on the other side. Now, I should say two things. Number one, and I'll highlight this. Number one, we can do these two steps together. So, but number two, that step of combining the variable terms of one side and the non-variable terms of the other side, that's where you're doing the addition property of equality. And that's where you're going to have the two sides interact with each other. The basic rule is you're adding the same thing to both sides. And so it's easy to kind of get mixed up about when you're allowed to do that. It's important to recognize that step one, when you're simplifying, you're not adding the same thing to both sides. You're not having the two sides interact. And step two, when you are adding the same thing to both sides, you've got to be really careful that you're not simplifying, or you're not trying to do simplifying type stuff with the addition property of equality. Okay, I'll show you what I mean in just a minute. And then finally, last step is you're going to divide both sides. The division property of equality, divide both sides by the variable coefficient. I'll explain what that means in just a second. Okay, so let's get down to brass tacks. We'll do a problem. And so I'm going to do the step number one. I'm going to simplify. Now, look at, I'm going to treat this as this big dividing line where I can't cross that line. On the right side, I've got 28, which is really simple, so there's not really anything I can do. But on the left side, I've got all kinds of operations going on, so I'm going to do those operations. I'm going to do the distributive property. That's the first step. And I don't even necessarily know what the next step is going to be until I've done that first step and then take a look at what I have left. So I won't even try to predict what we're going to do next. We have 3 times the quantity z, 5z minus 1. We can do that. 3 times 5z is 15z. And 3 times negative 1 is negative 3. And then 5 times the quantity 3z plus 2, that's 5 times 3z is positive 15z. And 5 times 2 is positive 10. And then I'm going to bring down the equal sign. And then on the right side, it's 28. There's no simplifying that can be done there, so I'm not going to try to do any simplifying there. But notice that the equal sign comes down, and everything that I didn't simplify or impact, I'm going to just leave. Now, I'm not going to do the steps of changing the order here. I think you can see that the next step is to combine like terms, and so I don't need to rewrite the problem so that the like terms are next to each other, but I find it helpful sometimes to just underline them. So I just say to myself, okay, I'm combining all the terms with z, and there's 2 of them. I underline them. 15z plus 15z is 30z. And then I'm going to combine the terms without z. That's negative 3 plus 10 is positive 7. Bring down the equal sign. I'm still not having the left and right side interact with each other. Now, I should have showed you what I was talking about, that confusing bit I was talking about where I said what to be careful of. a lot of people on this line will want to kind of ahead of schedule go in and apply the rules for the addition property of equality. So adding, so they say, okay, I see there's a z here and there's a z here, and so I'm just really impatient to get in there and subtract 15z from both sides. And that's actually a very common mistake. So you want to be really careful about that. You're not going to subtract or add anything to both sides until you've completely simplified, number one. And number two, you have to make sure that you're actually adding the same thing to both sides of the equal sign. So if you add something to the left side, you have to add something to the right side. So a lot of people get mixed up when they see this big left side. They think, oh, okay, I'm going to add something to both parts of the left side of the equal sign. And that's just not right. So we're going to scratch that out. So what's the next step? Well, actually, the next step is we can skip. Step B says combine all the variable terms on one side, and we've done it. They're right there. Z, all the z's are right there. 30z on the left-hand side. The right-hand side has no z's. So success with B. Good job. Step C is to get all the not z terms. So that's 30z. We've got 7 and a 28. Let's get all those terms without a z in them on the right-hand side. And so we're gonna subtract 7 from both sides with the goal of getting rid of the 7 that was on the left-hand side next to the z. And we met our goal. We end up with 30z equals 21. And then finally, we'll take the coefficient. The coefficient is a fancy word that just means the number next to the variable, 30. And we're just going to divide both sides by that number. And z equals 21 over 30. Now, I like to write that down, even though, you know, I know, I'm aware that that could be simplified. I like to write that down just so I can get it in my head. Okay, we have what z is. It's this fraction. The fraction can be simplified, but I'm going to think of it as a fraction before I start thinking about how to simplify it. 21 over 30, well, let's see. I know 21 is 3 times 7, and 30 is 3 times 10. So if I break it apart that way, I can see they both have a 3 in them, and I'm left with 7/10. So z equals 7/10. Now, keep in mind, this happens a lot. Happens a lot that our answer is a fraction, which does not make us happy when it comes to checking our answer and going back and plugging this back in and seeing if this indeed is the right answer. Still a good idea to check your answer. However, it is a very good idea to keep your answer in simplified or reduced fraction form. In fact, if it turned out to be an improper fraction, I would still say keep it in improper form. Don't change it to a mixed number. So 7/10 is a great answer here. Maybe what I would do in this case, instead of checking my answer back in the original problem, so instead of checking it here, where I'm going to end up with a bunch of fractions, 5 times 7/10 and 3 times 7/10, and then I have to deal with subtracting 1 and adding 2 and all that, I might say, well, let's go to the second step, because when I multiply 15 times 7/10, that's going to be a little bit easier to deal with. Okay, we'll see, but that would be my recommendation. Okay. Now, I want to show you a couple of more examples of these problems. So there's just a couple of tricks I wanted to show you. Everyone gets a little bit freaked out with fractions. And I think rightly so here. This 1/3 is going to just give us all kinds of trouble. 1/3 times s minus 2 equals s plus 4. Well, the truth is that even though I said you need to simplify completely first, and then apply the addition property of equality, adding adding to get all the s's on one side and then adding to get all the non-s's on the other side. We could, sometimes, it might be helpful to start with the multiplication property of equality. Multiplication property of equality says that I can multiply both sides of this equation by the same thing, and it will still be equal. And so if I choose to multiply both sides by 3, what would happen? Well, I hope you can see that if I multiply 3 times 1/3, and this is 1/3 times s minus 2, and so now it's 3 times 1/3 times s minus 2. If I do 3 times 1/3, that becomes just 1. 1 times s minus 2. And if I multiply 3 times s plus 4, that's distributive property. 3s plus 12. When I'm doing this, I have to be really careful that I don't get my s's don't turn into 5s. So this is the stage in your life where you really need to work on writing neatly. At least have some tricks that help you to be able to read your handwriting and know you're getting the right answer. Okay, or knowing what you mean to say, reading your writing. Okay, so can you see that multiplying by 3 had the effect of undoing or getting rid of that 1/3? And so that was a clever thing to do, even though it didn't technically follow the rules. So I just want to show you that you can break the rules if appropriate, as appropriate. Okay, let's go back to following the rules now. We simplified both sides of the equation. Now they're much simpler than they would have been if I'd multiplied by 1/3. Now let's get all the s's over to one side. Now there's two rules. There's two ways to think about this. One is some people like to have all the variables on the left-hand side. The rule is just get all the variables to the left-hand side. I think you can see here that if I was going to do that, I would subtract 3s from both sides and then end up with negative s's, which is fine. That's not wrong. 1s minus 3s is negative 2s. The other rule that you might want to follow is the rule of always subtract the smaller number from the bigger number. So in following that rule, I would say let's get rid of the single s instead of the 3s. So I'm going to subtract s from both sides, 1s from both sides. S minus s is 0, and 3s minus 1s is 2s. And there we have it. The s's are now all on the right-hand side. Now, either way is fine. You can make the rule be always on the left, or you can make the rule always have positive coefficient of the variable. Either way is fine, or you can just do it different every time. Now, let me demonstrate skipping or combining steps B and C together. So steps B and C, B says move the variable, all the s's to one side, and then move all the non-s's to the other side. So since the s's are on the right-hand side, I'm going to get any numbers that were on the right-hand side without an s to the left-hand side. And so instead of writing down that negative 2 and the plus 12 here, and then doing the moving the 12 over on the next step, I'm gonna do it on the same step as subtracting the s's. So I'm going to subtract 12 from both sides, and I get negative 14. And that saved me a line on my paper. All right, and now we can go straight to the last step, which is divide by the coefficient of the variable 2, and s equals negative 7. And I think it's a good idea to read left to right, so I'm going to, as my last step, turn it around. That's the reflexive property. Okay, let's see. We've got two more problems here. Let's do those. What if we have a problem like this, where we have 2/5, right? Last one we had 1/3 there. We wanted to get rid of the 1/3 by multiplying by the reciprocal. Now we have 2/5. So if I multiply by the reciprocal, I'd multiply by 5/2, which I can do. I can multiply both sides by 5/2, but then it's just taking the fraction and putting it on the right-hand side instead of the left-hand side. So one trick that you can do, and I like this trick, is you can multiply just by the denominator. Okay, as long as there's only one denominator. If there's more than one denominator, in multiple fractions involved, you can multiply by the common denominator. I'm going to multiply both sides by 5. Now, on the right-hand side, that parenthesis is already there, so I'm fairly safe. But on the left-hand side, there was no parentheses, so I need to make sure that it's 5 times the whole thing, x plus 4, not just 5 times 4. Okay, so now it's 5 times 2/5 times x minus 2, and x plus 4 times 5. Right, so I just took what it was there, and I multiplied each side left and right by 5. What's that going to do? Well, 5 times 2 is 10, divided by 5 is 2. So multiplying a fraction by its denominator just cancels out the denominator. And we're left with the numerator. Last time we multiplied by the denominator, we got multiplied by 3, 1/3 times 3, and we were left with the numerator, which was 1. This time the numerator is 2, so that appears to be a little more complicated, but it's not that bad. Now we're going to multiply the right-hand side by 5 as well, but I've reserved it for this next step because we need to do that same step here. We're going to distribute it, 2 times x and 2 times -2, and then we'll do 5 times x and 5 times 4. So just doing the kind of the mirror image steps together. 2x minus 4 equals 5x plus 20. Then I'm going to do the adding, or the same thing to both sides. So now I've simplified as much as I can. I've simplified so effectively that there's no fractions. So that's really nice. Now I'm going to do the addition property to get all the x's to one side. I think I'll go ahead and do my keep it positive rule. So I'm going to subtract 2x from both sides. And the goal of subtracting 2x from both sides was to get rid of the x that was on the left-hand side. So I'm going to get rid of the number without x on the right-hand side. So I'm going to subtract 20 from both sides. And I'm left with 3x equals -24. Then the last step, divide by the coefficient of x, which is 3. On both sides, the division, sometimes we call this the division property of equality. It's really the multiplication property of equality, multiplying by 1/3. -24 divided by 3 is -8. And 3x divided by 3 is x. And there's my final answer. Okay, let's do one more. And again, I want to show you this problem. This one says 3y minus the quantity 2y minus 1, the whole thing divided by 6. So we're going to apply that same rule. I'm going to take the entire fraction there and just multiply it by 6. And what's that going to do? Well, if I put it 6 over 1, it's really obvious. I'm going to cancel out the denominator there. So left, I have to, whatever I do on the right side, I have to do the left side. So even though I said simplify both sides separately, if there are fractions involved, it's often valuable to multiply both sides, do the multiplication property first, multiply both sides by the denominator of whatever fraction or fractions you have, so that you can simplify and get rid of the fraction parts of the problem. So 6 times the fraction with the denominator 6 just cancels the two 6's out, and we're left with 3y minus the quantity 2y minus 1 equals -1 times 6 is -6. Now, this is a really good tricky spot where we have minus parentheses. So anytime you have a minus parenthesis, that minus sign has to get distributed to both terms. It's best to mentally think of that as like -1 times 2y minus 1. So it's 3y minus 2y minus negative 1, which is plus 1. Now 3y minus 2y is 1y. We'll subtract 1 from both sides. And y equals negative 7. Now, I have not demonstrated here the really important step, I think, of checking your answer. You can always check your answer in the back of the book, and that's great. It's nice to have somebody else tell you you're right. But when you're doing this for real on a test, it's a great idea to take your final value and just plug it back into the original problem and see if it really does come out to be true. Thank you very much for watching. Have a great day.